Hello, welcome to the ETAP SCADA solution presentation. My name is Hugo Castro. I will be presenting the digital twin model-based SCADA solution from ETAP for electrical systems from generation to transmission, distribution, and industrial and commercial systems. We're going to start with an overview of the eSCADA solution. Next, we will review how ETAP uses the digital twin to perform analytics in real time. Then we will move to the graphical user interface and then finalize with some of the main features and capabilities of the system. Let's get started. The ETAP eSCADA solution is a modular and scalable solution for electrical power systems for any industry. It supports system operators to make informed decisions in daily and planned operations, such as opening lines, starting loads, shutting down operations, load transfers, and more. The eSCADA solution also provides multiple user interfaces for operators, engineers, and managers to be able to summarize information very quickly, in addition to the standard engineering tools that are available in the power system simulation version of ETAP. It is hardware agnostic. We have performed hundreds of projects with major and smaller manufacturers of hardware. Library of communications for specific devices are built in to make the integration faster as implementation happens. The solution is integrated with ETAP PMS, EMS, ADMS, OMS, OTS, and more. However, it is also integratable with third-party solutions. There is also a suite of integrated applications for automation, supervision, and operation of the electrical networks. There are two integrated features that differentiate the ETAP SCADA solution from standard SCADA systems. First, the predictive simulation or validate and predict before operate. And second, the playback function. The SCADA solution uses the digital twin model to perform real-time validation. It continuously analyzes the system looking for abnormal conditions in real time. The system generates analytical alarms based on capability of the components, including protection, cables, lines, transformers, generation sources, and more, without the need of instrumentation. It is based on the digital twin model and operation conditions. The SCADA solution also provides the tools to predict electrical system response before an operation is executed, when the operator needs to perform network topology changes, circuit breaker operations, motor starts, generator operations, and more, including load transfers. They can simulate and validate the response of the electrical network to avoid unforeseen conditions such as overvoltage, undervoltage, underfrequency, protection system operations, power quality issues such as resonant conditions. The predictive simulation allows you to see the steady state and dynamic response of the electrical network. The eSCADA solution also allows you to go back in time throughout its playback system to reproduce, diagnose, verify, and analyze past events. The operators and engineers can load historical data into the simulators to reproduce events and analyze alternate conditions. We have seen customers compress 3 to 4 days of diagnostic work after an event to a few hours, or to identify reasons of conditions and come up with alternate solutions in minutes. This is a time-saving and money-saving capability. Let's look at the ETAP real-time system. Here we're looking at the digital twin model within the ETAP software. We look at the digital twin, the status of all the different devices. We look at the real-time data, the data in blue, that's coming in from the field. This is coming from RTUs or meters in the system. We select to display the digital twin calculated data from a state estimation. The state estimation allows us to monitor the field even in locations where we don't have metering devices, in addition to validating the electrical system model. The electrical system model, with a click of a button, can be actually compared with the actual real-time data and easily identify any large deviations in the system, which might mean, one, a big difference between the digital twin and the actual system, and second, it could mean that there is a miscommunication between the field devices and the electrical system model. The software identifies, it gives you different flags that tell you if the problem is communication or the problem is the digital twin model. So with a click of a button, we have saved hundreds of hours of validation of the electrical system model by just comparing the real-time data with the simulated data in seconds. After seeing the information in real time coming into ETAP, let's look at the validate before operate functionality. The validate before operate functions allows us to answer operation, planning, and switching questions in real time. ETAP allows us to perform the actions in simulation mode while using real-time operation data and see the results of such actions. The full spectrum of analysis modules in ETAP, such as the load flows, the short circuit, protected device coordination, transient stability, motor acceleration, harmonics, and more, can be utilized to determine the system response after different events. Let's look at that. Let's set up the system for simulation. First, I'm going to open another presentation or view of the one-line diagram and place it in load simulation mode. Now we see two presentations side by side, one in real-time mode and the other in simulation load flow mode. Next, I will execute an action, such as opening a breaker. I execute the calculation, and we see the system overload for such condition. I can also simulate a load increase. In this case, I am increasing the load by a factor of 10. I perform the calculation and see how it affects the conditions of the system. In this case, we see an overload in the two-winding transformer. Now let's look at the general system architecture of the ETAP real-time solution. In this diagram, we can appreciate the architecture of the system. The system can be distributed across different servers as it is depicted here, or we can centralize it in one machine, depending on the size of the electrical network and the number of measurements to be monitored. Given its interoperability, the system communicates to various hardware independent of the brand, including meters, controllers, RTUs, gateways, protection relays, and more. With this, we get a seamless integration. We have an application called the SCADA integrator that allows us to map from a library of components to the different meter relays and devices. It is a robust client-server architecture, multi-redundant system, scalable, modular design. You don't have to get all the functionality of the electrical network solution of the real time. So it's completely modular. It has a multi-tier user access management. It's hardware independent, as I mentioned. And it's also available in a virtualization mode. You don't have to have physical hardware in premise. You can use hyperconvergence servers to run virtualized solutions in premise or use virtualized solutions in the cloud. The ETAP eSCADA solution is a server client system. The clients are the stations where engineers, managers, and operators will analyze and operate the system. There are three clients that ETAP provides: engineering, operations, and web views. The engineering station is an enriched environment with all the analytical tools designed for complete technical analysis of the electrical network. Engineers and advanced operators will be able to create what-if cases and analyze in detail the outcome of such cases. It is perfect for detailed diagnosis of the electrical network. The operation station is designed for operators. It has a simplified interface specific to operator needs. It is personable to operator preferences. The eWeb solution is for more remote operations and maintenance crews. Most information is available as it is in the operator stations with no control by default. Alarms and events, trending reports, and dashboards are compatible across the operations and web dashboards. Not all stations work from a single digital twin with a single access level management and integrated solution. As I mentioned earlier, ETAP provides an open platform capable of communicating with third-party hardware, software, using standard communication protocols. By default, ETAP provides the communication protocols and interfaces listed in the left, including the IEC 61850 MMS, Modbus DMP, ICCP 60870-104, OPC, and Aviva Pi communications. However, ETAP can also provide hardware or virtual expansions for additional protocols listed on the right. Hardware digital inputs, digital outputs, analog inputs is done by the ETAP ICE hardware as a complement to the front-end processor of the ETAP real-time system. Now let's look at more detailed functionality of this eSCADA. Let us start with the administration of the system, including HMI, synchronization, and process manager. The User Access Manager allows the administrator to configure access to the system. It is based on area of responsibility and roles performed by each user. The User Access Management defined here is used across all applications, including HMI, eWeb, alarm management, control, and more. The User Access Manager works with your domain controllers or independently in applications and workgroups, defined by the preferences of the system administrator. One of the great features of the system is the cloud-based synchronization of the clients. As the electrical network keeps evolving and enhancements keep coming into the model and interfaces, the NetPM application interconnects all clients to share information. The typical configuration is to configure a development server where all the updates are performed and tested. The users from this server can push the tested updates automatically to the clients by selecting a function in ETAP. So let's look at this feature. We can see here two presentations. One is in real-time mode. The other machine is the development server. That development server is on a different computer. And right now the system is set up to automatically synchronize. So if I take the development server and I start making edits, you will see that on the remote client or real-time client, the updates are being implemented. So any changes, such as, for example, adding components. In this case, I'm adding a circuit breaker. I'm going to add a load. As I'm making the changes, they are synchronized on the real-time system. So information, all the information, including the technical data, is also synchronized. So for example, I'm gonna look at that load. I'm going to go into the development server and make it a, let's say, at 100 MBA load. Put in that information, click OK. You will notice that if I go and access the same component, that information has been updated into the real-time presentation. The system can also operate in a manual acceptance mode. And what that means is that I can make configurations in the development server and not synchronize automatically into the real-time server. We have a client which we call the NetPM manager that allows us to actually control the changes. So the NetPM buffers all the changes, and you can see here that they are recorded. They're coming in from different stations or going to different stations. The information is recorded. It's telling you that it's going to connect new components or make edits to individual parameters and so on. So you have the option to download if you are in the client or upload if you are in the development server, and actually make those changes to the system. So you have to have administrator privileges to actually select the changes that you want and send them to the individual stations. Now let's look at the Process Manager application. This application in ETAP, eSCADA, allows the information technology, IT, operation technology, OT, administrators to monitor all hardware and processes of the eSCADA solution. When processes or hardware go to abnormal conditions, the operators and system administrators are notified via the alarm system, SMS, or email if desired. Some of the parameters monitored by the Process Manager include ETAP services and applications, status of IP devices, including meters, RTUs, Any process failure, the system will generate alarms when this happens. It also has the capability of auto restart the application when failed. It also look at the resource usage, archive data validation, database synchronization status, whether the SQL Server or system databases are synchronizing. It also looks at the front-end processor management, looking at the load sharing status, device failovers, device statistics, and also requests of scan and freeze data updates. Let's look at the interface of the process monitor. What we can see here is we can see all the different processes on the different machines. We see the CPU usage, we see the handling count. We can look at individual services, we can kill those processes, we can restart those processes as we need on the system. We can go to individual consoles, for example, and we can actually connect to those consoles. Well, we also see the data synchronization of the different databases. We can do the start of those synchronizations for alarming and so on. We can also look at the front-end processor and see if the communication is connected, which protocol is connected. We can disconnect, we can reinitiate, we can restore the communications via this interface. Now let's look at the applications of the eSCADA solution from an operations perspective. We're going to look at the human-machine interface, look at the remote control functionality, alarm management, tabular dashboards, alarm and event history, user-defined reports, operator notes, and trending. The human-machine interface, or HMI in ETAP, allows the user with a friendly interface for operators to have the system information on dedicated HMI pages or dashboards. It allows you to monitor information very easily in customizable HMIs, personalizable for each customer. Look at the information through one-line diagrams and even geographical information views. You can have access to alarm and events, logs, real-time and archive trending, remote simulations, specifically for low flow and short circuit. Also a look at energy accounting data and more. The system goes through a high level of security client-server authentication. You can actually operate the system from these HMIs, perform control of all switching devices, and tap changing position of transformers and generators. Now let's look how do we create those dashboards. Here we have an application called the ETAP HMI Designer. The ETAP HMI Designer allows us to import the digital twin model from the ETAP power simulation software. From here we can customize it. We can add different components such as gauges and different trending views and so on into the dashboard. We get that from the library of components or user-defined components that we can create through this designer. Then we deploy the HMI. We bring it into the runtime view of the, or what we call the ETAP SCADA view, from where we can create different navigation methods, including links. We can look at the different components, the status, bring the real-time data, generate trends. All this information is auto-mapped from the same database that was used to map the ETAP real-time system. Therefore, there's no need for additional work or mapping to generate these views. Here are some other examples. So we can look at the HMIs, how do we access information like control commands and so on. As you can see, we can create different templates. This is completely customizable for the customer. So templates that can be, for example, executed by double-clicking on a component or single-clicking. You can generate the different views, perform different commands, look at the status on those mini dashboards, for example, pop-up dashboards that we can create for each of the elements and components. And these are all based on templates. So you can create one template for a type of component, for example, transformers, and use the same template over and over. You can also do the same for relays, protection devices, metering devices, and so on. So the development and creation of these templates is very simple, and ETAP can also provide you with already created templates for implementation. Now let's look at the remote control capabilities of the ETAP system. So the remote control capabilities are very customizable depending on the system. So you can generate many type of controls and add the control commands through the interface in the dashboards. So you can create controls, for example, for initiating start or initiating stop for generators, be able to trip or close different switching devices such as circuit breakers, reclosers, and so on. Perform controls on transformer taps. You can have user-defined control actions. In other words, you can create control actions that are based on different operating conditions. You can do user-definable controls through calculation tags, which means that under certain conditions, you can actually initiate controls. There's also options to select the type of control, so you can have a two-stage control select before operating system, or actually just press a button and send a control command. So let's look at the control commands. So here, for example, we're looking at the system where I can actually send switching controls to the system. So I can set it up, for example, by double-clicking and selecting the command to send direct controls, or use the select before operate function as well, where I have to select the component before actually sending a control command to the system. Now let's look at the alarm manager. The alarm manager allows you to look at different types of alarms, including the SCADA alarms, analytical alarms, which are calculated by the state estimation when it's doing the real-time evaluation of the digital twin. Or you can also create system alarms. The difference between SCADA alarms and system alarms is that SCADA alarms are based on the measurements that we're bringing in from the field. The system alarms are based on the status of different devices that make up the SCADA solution. So for example, the status of RTUs, the status of metering devices, the status of servers, processes that make up the eSCADA solution, as we saw on the process manager. So the alarm management allows you to configure different alarms based on the measurements. You have a complete control of the alarm solution, where you can actually, in the interface, be able to acknowledge alarms, delete alarms, mute or unmute sound as the alarms are happening. You can actually do a complete silencing of the alarm system if required. The view is completely customizable based on the preferences, what we call themes, that can be configured. So each user, for example, can use different themes depending on the information that he's interested on and the coloring, and basically customize it based on how he wants to operate. However, the administrators can also set up a standard alarming system depending on the policies of the company. Here we can see the user interface of the alarm management. As you can see, we can select alarms, we can acknowledge, we can delete alarms, we can mute alarms, basically take actions or manage of the alarm system. As you can see, the alarm manager applies different coloring depending on the themes and so on. We can take specific alarms, locate them in the HMIs or in the digital twin model in ETAP. We can prioritize alarms. All of that functionality is available through the alarm viewer. Another great application within the ETAP system is the tabular dashboard. In other SCADAs, you manually have to create the tabular dashboards to display the data that you want to see for different components. In ETAP, this tabular dashboard works automatically. It allows you to monitor all the different tags in a tabular form. You can observe all configuration tag details from different values, for example, current values, states, alarms, quality. It provides you with a component view where you can actually observe the information via components. Let's look at the tabular dashboard. Now we see here the tabular dashboard. The tabular dashboard gives us a listing of all the measurements in the front-end processor of the ETAP real-time system. So we can actually look at the current status of every single component. It gives us information about the quality, gives us information if there's a bad communication. It includes all the analogs, all the digital values, measurements, and so on, including color coding of different conditions. All that information is stored in the tabular dashboard database for easy access. From here, they have different options. For example, if I want to look at the measurement details, so for example, looking at the limit overrides, so that means the alarm overrides, for example, for each individual tag, we can do it from this interface. From here, we can locate the components on the SCADA HMIs, on the ETAP digital twin. We can actually add nodes onto each of the devices. And also navigate to the alarm viewer if any alarm is created. This view has a lot of information, so therefore we provide a data filtering mechanism that can be stored per user. So this data mechanism allows us to filter information that is important to the specific user. So you can do this based on divisions, substations, and basically keep track of the information that you need immediately through this interface. Another application in the eSCADA solution is the alarm and event management. This allows us to look at the historical information of the eSCADA solution. So it allows us to go back in history to look at alarms, warnings, events based on measurements, status changes, sequence of event data from the different communication drivers and devices. The viewer includes the capabilities of looking at the specific time periods and filtering information as we need. So the event viewer allows us to look at the historical data. So you can see that we have very detailed timestamp of the system. We can go and add comments, look at data from the playback view, bring that information to the analysis modules. So we can look at that information in very detail. The viewer also allows us to create different filtering. We can create different themes or specific views per user so that they can look at the information that is applicable or important for that particular user. Another key application that is available in the eSCADA solution is the user-definable reports. The user-definable reports are based on three different applications. One is the report designer, which allows us to create a template for the reports. The HMI viewer, which allows us to look at and access the reports through the user machine interface on the workstations, operator workstations. And also the web viewer, which remotely allows managers and operators and crews to be able to access information via the web. So the reports, there are two types of reports. There can be on-demand reports, which means that they can be generated at the moment, or they can be scheduled reports. The scheduled reports are basically reports that are generated at a specific time during the day, and they can be saved as files or emailed automatically to different groups of users. The reports can include archive measurements. The archive measurements are divided into measurement groups depending on the type of reports that are created and added to different report templates for easy access of the information. The reports can be generated in two different formats. One of the formats is the Excel view, and another is the PDF view that files can be exported and saved as required. Another application that is worth mentioning is the operator nodes. The operator nodes allows the operators to actually place nodes on components or views directly on the one-line diagrams or HMIs in the system. It allows you to communicate to operators information about operation status and components across the different workstations as well as across different shifts. The information can be defined to be active for a specific time ranges. There are different types of operator nodes and priorities. The different types and priorities define the different symbols that are used on the OLBs or HMIs. Independent viewers or common views of the nodes can be open. There is capabilities of using the operator nodes also to generate control inhibition. So, for example, if there is a crew performing a maintenance on a specific device, the operator can add an operator node on that specific device as a control inhibit node, and the controls are going to be disabled from the SCADA until either the node becomes inactive or the operator manually removes that operator node. It also is recorded in the event log as an event generation. So there's always tracking of all the different operator nodes that are created in the system. Here we have an example of an operator node. So you can see the symbol on the one-line diagram. So you can see, for example, in this particular case, we're using an alarm symbol. Now the symbol is depending on the type of operator node. So in this case, you can see that we can choose different operator nodes, like a scan inhibit, which means we stop scanning data. We have control inhibits, alarm inhibits, and so on. Maintenance, informational, PTO, and more of that information. So we can have the active from and to times that are defined here. Information who's the user who put it in, the machine from which the node came from, timestamps are all updated and recorded in the service tag dialog, and also can be viewed through the event log. Another feature that we're going to look at is the trending. The trending allows us to trend information from the different measurements that we're collecting from the field. So the trendings can actually be added as links from different devices, or you can actually access the trending system directly on the user interface in the human-machine interface or HMI of the system. The software allows you to do user-defined time ranges, which is actually looking at a specific historical data from the system, or also trend in real time. The information can be exportable to different formats such as CSV and Excel, and there are multiple functions or interactions in the system, such as being able to add or remove the different trends, be able to zoom in, zoom out, be able to save those charts, put the charts together, look at the tabular forms, look at minimum, maximum values and average values on the trend. So there is a lot of functionality to make the operation of the trend view very easy. So like I said, you can create links like this or access the trend view directly on the HMI application. That brings us to the conclusion of this webinar. There are many other functionalities that are exciting and allows us to operate our electrical systems in a much more efficient way. So feel free to contact ETAP if you would like to have more information about the eSCADA solutions specific for different industries. So there are functionalities specific for example, renewable systems where the eSCADA solution works with our controllers, such as the microgrid controller and power plant controllers. We have SCADA solutions for generation control and so on. So feel free to contact us if you have any questions. So in summary, what we have learned today from this webinar is that the ETAP solution is a digital twin model-based solution. It has integrated predictive simulation and for before you operate modules, a modular and a scalable solution for electrical power systems for any industry. It's hardware agnostic. We can communicate to any hardware as long as they're using standard communication protocols such as IEC 61850, Modbus, DMP3, IEC 104, ICCP, and so on. It contains a suite of integrated applications for supervision and operation of the electrical networks. So thanks again for watching this webinar, and if you have any questions, feel free to contact us. Thank you.